Good morning, dear students. Children, welcome to your another session of your online classes. Children, we have started lesson number 10 and today is the second part of the lesson. And children, in my previous part of this lesson, I took very basic concepts, especially that you have learned in your lower classes, 6th and 7th standard. Children, I am going to take this lesson in the whole week and I'll be taking it in very small parts so that you can understand. In case you don't understand, please do give me your feedback on my email address. Now, children, I'm giving three conditions to you and tell me in which of these three conditions you are able to run very fast. Right? Now, let us consider a scene of a market which is highly crowded, and second is let us take a playground which is totally empty. Now children, out of these two situations, in which of the situation you will be able to run very fast and why? Yes, definitely you will be able to run very fast in a playground. The reason is presence of lot of empty spaces. More is the space, more will be your speed. Children, something similar is the behavior of light. Light, which is a form of energy, okay, and children, light is able to travel through a solid medium, through a liquid medium, as well as through a gas medium. But it travels fastest when it gets lot of empty space. That is why light travels fastest in a vacuum. Vacuum is a place where there is nothing, no air is there. Okay, so here in this particular slide you can see three cases in which the molecules of solid, liquid and gases are arranged. So children, in this particular example, light will run very fast through the gases because lot of empty spaces are there. Okay, and in case of solid, which can be an example of a glass, okay, so here you will find that empty space is less and here the speed of the light will decrease. Okay, so from here you get two new concepts: optically denser medium and optically rare medium. So in which light is able to travel very slowly, it will be called as optically denser medium, and in which light travels very fast, it is called as optically rare medium. So children, air is an example of optically rare medium. Let's go to the next concept. Okay, refractive index. What is it? Very simple, children. Okay, now there are different things around us. Okay, now children, I am specially talking now only about the transparent thing which are around us. So the transparent thing which is around us is of course the air, and water is also a transparent substance, and glass is kach is also a transparent substance. Now children, through this transparent substance, the light will pass. Okay, and children, when the light will pass in a gas, when in a air, when light will pass through the glass, or when the light will pass through the water, every time the speed of the light will be affected. Okay, and what is mean by refractive index? Do not get confused by such a big name. It is nothing, children, but just a ratio of. It is nothing but the ratio of speed of the light in any two medium. Okay, any two. When we compare, we can do comparison only between two things. Okay, comparison. You have studied this in your English concept, children. Degree of comparison. So, what is a refractive index? Nothing but just a ratio of speed of light in any two medium. Okay. So, children, let us consider the speed of uh, light in medium one is v1 and in another it will be v2. So we come. So children, here you can see in the picture, this is the ray of the light and here is the water. So here the velocity of the water will decrease. So here we get two medium. One is the transparent air and another one is the transparent apparent water. Okay. Now refractive index. Okay, children, you remember incident ray, in the reflection of, this is angle of incidence, this is our normal line. Okay, and children, this is the second medium, this is air, and the second medium is taken as the glass. Okay, so refractive index means velocity of light in air is taken as n1 and n2, the refractive index n2, that is the velocity of light in glass. So say a similar thing, children. This is a picture of a glass slab. Whenever you will come to the school in this particular session, I'll take this lesson once again. Do not worry. Okay, children. Now, refractive index. Refractive index, medium 2 with respect to medium 1. Okay, the speed of light in medium 1 and speed of light in medium 2. Okay, and it is given as n21 is equal to v1 upon v2 है ना. So because we are comparing from 2 to 1, अगर हम 1 to 2 करेंगे, so here it will be n1 2, and here upper one will be 2 and lower it will be 1. Okay, and children, this particular lesson is very important, and this particular concept is also very important. So I hope you have understood refractive index. Okay, the above expression gives you the refractive index. So children, I hope you have understood what I have wanted to explain you. Now, what is meant by absolute refractive index? Okay, now absolute refractive index means when we are trying to compare the velocity of light in two different medium, and one of the medium is vacuum. Vacuum मतलब ऐसी जगह जहाँ पर कुछ भी नहीं है. Okay, so children, when we will cross earth, suppose by God's grace some of you become scientists, astronauts, and you visit different planets. So children, when you leave earth, we leave the atmosphere also behind it, and let's say you land on moon. So on moon it is vacuum, air is not present. Okay, so absolute refractive index means we are trying to compare the velocity of light in two medium, and one of the medium is taken as vacuum, and second medium can be anything. Okay, so children, in this particular case we have this particular formula. So refractive index is denoted by n, and absolute refractive index is denoted by n2. Okay, n2. So thus n2 is equal to speed of light in vacuum divided by speed of light in a particular medium. Now this medium can be anything. Okay, and children, the absolute refractive index, when we get the different value, that will help us to know that uh, and in this diamond gets the highest value. That is why real diamonds are very precious. Yes, they are precious for some other reason also, but this is also one of the reasons. Absolute is slightly faster. Same formula, children. So refractive index of is given as, children, speed of light in air. It is denoted by c, and speed of light in any medium is taken as v. Now let us understand what is meant by optical density. Okay, closer are the molecules, more is the density, more is the optical density. That means less will be the speed of light. Okay, here let us children consider two examples, alcohol and kerosene. Both of them are transparent liquid, and their refractive index of kerosene is 1.44, and another for alcohol it is 1.366. So children, in case of alcohol, the velocity of light will be more, and in case of kerosene, it will be less. Similarly, if we compare, when we compare water and kerosene, kerosene is optically denser. That means here the velocity of light will be less. Okay, and children, optical density is nothing but it is the inverse. Inverse means ulta, opposite the measure of speed of light. So more optical denser, less is the velocity. Less is the optical density, more will be the speed of light. Right? Now, let us understand, children, what is meant by refraction, which is actually which comprises the first part of our lesson. Refraction is nothing, children, but I've taken this particular example in the center. Children, it is nothing. See here, you can do this particular example in your home also. Take a glass of water, कांच का ग्लास लीजिए और उसमें अपनी पेन या पेंसिल कुछ भी डुबो दीजिए, and you will find that it gets little bit tilted. Why does it happen? It happens, children, because here, see, here, outside it is air, so optical density of light of air is very less. So here light travels very fast, whereas in case of water, transparent water, what happens? The velocity of light decreases. And children, when it happens, what happens? The light bends. When light travels from rare medium to denser medium, it will bend. Now, where it will bend, children? It will bend towards the normal. Normal, you remember in my first video, I taught you about reflection of light, laws of reflection of light. So, there I told you that whenever we draw a perpendicular line to the point of incidence where this particular light is falling, which is written as P. So I hope you have understood, children, what is meant by refraction. Bending of light towards the normal. When light travels from rare medium to the denser medium is known as refraction. Now, children, normally speed of light in vacuum, it is taken as 3 into 10 to the power 8 meter per second. Okay, and light travels in different medium. It travels fastest in the vacuum. So in this today's session, I have taught you two very important concepts, right? So please remember them, learn them. In case you don't understand anything, please do give me your suggestions on my email address. And many of the students have my WhatsApp number, so children, you can take my WhatsApp number even from your class teacher and call me if you have any serious issues. So children, it was all about today's topic. Thank you. Take care of yourself. Bye.